Hello viewers, in today's class we are going to discuss one important problem from differentials, that is approximations. So here in this session we are going to find the approximate value of this expression, that is cot inverse 1.004 using the concept of differentials, right? So let us first quickly see the concept of differentials, and then we'll see the procedure how to find the approximate value of cot inverse 1.004. So let us consider a function y is equal to f of x, right? Now let us make a small change in the independent variable x, and the small change is represented by delta x, right? So when we make a very small change in the independent variable x as delta x, there is a corresponding change in the value of y, right? So let us denote the change in the value of y, that is delta y. So delta x is the increment or the change in the value of x, and delta y is the increment in the value of y, right? So now this equation can be written as y plus delta y is equal to f of x plus delta x, right? So this equation number 2, it suggests that when we make a small change in the value of x, that is delta x, then it becomes x plus delta x, right? And the corresponding change in the value of y is delta y, so that the new value of y becomes y plus delta y, right? Okay, now let us replace this y by f of x. So we have f of x plus delta y is equal to f of x plus delta x. So delta y is now equal to f of x plus delta x minus f of x, taking this f of x to the right hand side. Now dividing both sides by delta x, we have delta y over delta x, and here we have fx plus delta x minus f of x divided by delta x, right? Now see, delta x is a very small quantity. So when delta x tends to 0, or taking this limit, that is delta x tends to 0, we have this expression is now denoted by the derivative of y with respect to x, and here we have limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x, right? And this expression can be written as f prime of x. So we conclude that this limit is equal to dy over dx, right? That is dy over dx is equal to the limit delta x tends to 0 and delta y over delta x, right? Now since delta x is a very small quantity, and similarly delta y is also a very small quantity, so we can now take dy over dx is approximately equal to delta y over delta x. So here we approximate dy over dx is equal to delta y over delta x, because delta x being a very small quantity, it approaches to 0, right? So now we have this equation, right? So we can also rearrange this equation as delta y is equal to dy over dx times delta x, right? So this is a very important equation or expression in differentials or in approximations, right? So we can conclude that delta y is approximately equal to dy over dx times delta x, right? And to solve this problem, we are going to use this expression, and let us see how we can apply this concept to get the approximate value of cot inverse 1.004. So let us first frame a suitable function, that is y is equal to f of x. So here since cot inverse is involved here, so we can take the function as cot inverse x, right? Now let us find out the derivative of y, that is cot inverse x with respect to x. So we have dy over dx is equal to the derivative of cot inverse x, which is we know that the standard formula, that is minus 1 over 1 plus x square, right? So dy over dx is negative of 1 over 1 plus x square. So now let us inspect this quantity. See, here we have cot inverse 1.004, right? Now we can write this quantity 1.004 as 1 plus 0.004, right? So that we can take this 1 as x, and there is a small increment in the value of x, that is 0.004. So we can treat this 0.004 as delta x, right? So now we have x is equal to 1, and the small increment in the value of x is 0.004. So now we have the value of x and the increment delta x. Now we need to find out the increment in the value of y, which is denoted by delta y, right? So for getting delta y, we need to find out dy over dx, and delta x is already known to be 0.004. So let us find out dy by dx by taking x is equal to 1 in this expression. So dy over dx at x is equal to 1 is given by minus 1 over 1 plus 1 square, that is minus 1 over 2. 1 plus 1 square is 2, so that is minus 0.5. So now substituting the value of dy over dx and delta x in this expression, we have delta y is equal to, here we have minus 0.5, dy over dx is minus 0.5, and delta x is equal to 0.004, right? And if we multiply these two quantities, we'll get minus 0.002. So the approximate value of delta y is equal to a negative of 0.002. So now we need to find out the value of cot inverse 1.004, right? So for this, what we will do, we'll take help of this function, that is y is equal to cot inverse x, right? So when we make a change or a small change in the value of x, there is a corresponding change in the value of y, right? So we have y plus delta y is equal to cot inverse x plus delta x, right? And here y is cot inverse x, and delta y is negative of 0.002, and x plus delta x is equal to 1.004, right? So x plus delta x is equal to 1.004, right? So now the value of y can be obtained by y is equal to cot inverse x by taking x is equal to 1, right? So y is equal to cot inverse of 1 because x is equal to 1, and cot inverse 1 is pi by 4 because cot pi by 4 is equal to 1, cot 45 degrees is equal to 1, right? So here for y we can now write pi by 4. For delta y we can write negative of 0.002, and here we have cot inverse of x plus delta x. So x plus delta x is our 1.004, right? So cot inverse of 1.004 is equal to pi by 4 minus 0.002. Now pi is 3.14, so when we divide 3.14 by 4, we get approximately 0.786, right? So here we have 0.786 minus that is 0.002. Now when we subtract these two quantities, we get approximately 0.784, right? So the value of cot inverse 1.004 is approximately equal to 0.784, right? So viewers, this is how, by making use of the concept of differentials, we can find the approximate value of given quantities.